Okay, so this is problem 22 of chapter 11 of Giancoli 6th edition. So to solve this problem, you have to look at a graph. And I'll try to make a graph here, but look at the problem, look at the figure in the web assign. Okay, so to understand this graph, you have to understand, read in the problem what the increments mean. Okay, so what is the idea? I have here the vertical x. Okay, so I have here the vertical x, and I have here the xx. The vertical x is giving us the displacement of this object. The vertical x is in meters, and the xx, the horizontal x, is giving us the time, and the time is in seconds. Okay, so this is the displacement in meters and time in seconds in the horizontal. Okay, so what is the increment? Well, this position here is 0, equilibrium position, and the first increment is this, and that this is the second, this is the third, fourth, and so on. In my problem, they say that the increments in the xx is 1 meter. Okay, so this point is 0, this is 1 meter, this is 2 meter, this is 3, this is 4, and so on. For time, they say that it goes in increments of 0.5. So this is 0.5, this is 1, this is 1.5, this is 2, and so on. Okay, so let me start with curve A. So curve A goes like this. It starts at 0, then it goes up at time 0.05. It goes very close to something like here, between 2 and 3. Okay, so my figure is not so good. Between 2 and 3 here. Then at 1, it's back to 0. At 1.5, it will be again between 2 and 3 in the negative side, and at 2, it's 0. Okay, and then comes the question now, what is the amplitude? So the amplitude is this point here. Okay, it's between 2 and 3. So the amplitude for this curve A, this amplitude is 2.5 meters approximately. Okay, then comes the question, what is the period and the frequency? Now first is the frequency, and then is the period. It's easy to go straight to the period, because the period is the time to complete the cycle. So the period is the time to start here at 0, go all around, and come back to that same point again. So you see that the period is 2 seconds. Okay, it's 2 seconds, and the frequency is 1 over the period, so the frequency is 0.5 hertz. Okay. We also have to find the equation for this curve. And what is the equation? The equation for the position, right? The equation is the amplitude, and we just found the amplitude is 2.5. Now I have to decide if I should use a sine or a cosine. Since at time 0, the position is 0, I know this has to be a sine. Okay, so this is a sine. 2 pi frequency, I have the frequency is 0.05, all that multiplied by the time, and this is the equation. Okay, let's now go for the other curve. And what we have? Well, the other curve starts more or less at the position 3.5, right? It starts between 3 and 5 here at this point. Okay, so I'm going to start there, and I see that the amplitude, I gain the amplitude again, but compressing the spring at time 0.5. So I go from here 3.5, all the way to minus 3.5 when the time is 0.5. Okay, so here I reached again the amplitude minus 3.5. Then I move again, and then at time 1, I'm back to the same point. Okay. Okay, so my drawing is not very good. Look at your drawing at WebAssign. But you see that if I have to get, again, amplitude and frequency and period, what do we have for this part, for this curve B? Well, we have that the amplitude is 3.5. That's the point where it started, the maximum displacement. The period, it takes it 1 second to return, to do the whole cycle and return to its initial position. So the period is just 1 second. Frequency is 1 over the period, so it's also 1 hertz. Okay? Now, to write the equation of motion for this curve B, I start with the amplitude 3.5. Now, should I use cosine or sine? At time 0, I'm at the maximum displacement. I'm at the amplitude. So, I should use a cosine. Cosine of 0 is 1, right? So, I should use a cosine and put there 2 pi frequency. Frequency is just 1, and the time. Okay? So, let me repeat here. In this problem A, we have that the time, at time 0, the displacement, the position is just 0. So at time 0, my position is 0. I know the sine of 0 is 0, so that's why we use sine here, right? The other curve, curve B, at time 0, we were at maximum amplitude. We know that the cosine of 0 is 1, so this is why we use cosine here. And that's the end of the problem.